Welcome to another tutorial on MATLAB. In this particular tutorial series, we are looking into the concepts related to Simulink. And in this particular video, we will just summarize what we have learned in the previous tutorials. We will wind up with that. And we will also, in the next video, we'll start implementing the real scenario based lookup tables, which will make some sense to apply it. So basically, if you come to lookup tables, why lookup tables are being used, it is just being used to simplify the logics that are interpreted between the inputs and the output. So suppose you have two columns which are input 1 and input 2, then in that case it will be very easy for you to implement the same relationship with an output, and with the help of a lookup table you can do this very efficient and fast. As we discussed last time, right, we have multiple methods like cubic spline, linear point slope interpolation, and we have also flat interpolation, linear Lagrange interpolation, and nearest neighbor interpolation. So these are the all algorithms that are present, and if we come to the uses, then or the performance or the sum of the criteria through which we want to judge it, then in that case linear slope is a moderately smooth, like if you see the smoothness part, like how much smooth it will be. So in place of linear point, it will be smooth but moderately smooth. The nearest point and the flat, these two algorithms will not be smooth. It will give you the results based on whatever the output values that you given, and based on that it will give one of the output. Linear Lagrange is also moderately smooth because also it is using a linear type of equations, and cubic spline will be very smooth as it will be having a first order and second order solution. Coming to the computational complexity for linear slope, it will be low, and for linear Lagrange it will be moderate. So as you can see, if any case like you want to like apply both, and it is giving both same performance, then in that case better to use the linear one, because the computational complexity for the Lagrange is high. If you see the cubic spline one, then in both the area, like in the smoothness it is fine, very high performing, and also in the computational complexity also it is very high. So basically you are computing very large amount in case of cubic spline. But yeah, if the problem needs that, then you need to apply it. So we will also see like what is the best scenario and the worst scenario. It is best for like the linear one is best for simple data interpretation. So if you want to do simple data interpretation, best way is to deal with this by linear point slope. And if you have discrete points, like you do not have continuous point but you have discrete point, then in that case the nearest neighbor and the flat will be the best options. So you cannot, like suppose you have a switch which you can either turn on and off. Now you need to choose which one you need to do. So in such scenarios, the discrete will come into picture, and the nearest neighbor or the flat one you can use. So that will be the best scenario where you will be using it. Next is like for linear Lagrange. So small numerical data sets, like if you have the data set very small, and there you need to do the prediction, or you need to interpret like what should be the midpoint in between those 2 points in which you want to predict, or what is the point that you want to determine, then in that case you can use such linear Lagrange one. And yeah, if you are going for cubic spline, then in that case, you like if the curve is very smooth and actual approximation can be done, then you can use that cubic spline. So the curves which are very smooth, in that case, you need to do the cubic spline one, so that you will be able to predict very accurately. So most of the real world scenarios, you will be using cubic spline. But yeah, suppose if you want to map something and things are very linear, so in that case, better you do with the linear interpolation. So this is mostly being used for many applications. So coming to the worst case, what could be the worst case for this algorithm? So um, the poor accuracy will come for linear interpolation is when the data is having some curves. So if there is curves, then you will get more error for linear interpolation. And for nearest neighbor and the flat, if there is a sharp transition or unnatural results, if you are having in your data, and the data is very large, then in that case it will be like the worst case for this type of algorithms. They will not perform good. Next is the linear Lagrange. So yeah, here like if you have insufficient data, then you will get a large error. So the data should be sufficient enough. At least here we are taking small amount of data, but this data should be sufficient enough, then only it can perform better. So linear Lagrange will only perform better with a less amount of data, but the data should be sufficient. Next, coming to the cubic spline. So here expensive for large data. So you can have like data which is very smooth. That means you are having large data. But in this case, like if it is very huge data, then in that case it will be very complex, or the worst case for the cubic spline to do the computation, because it is already computationally very expensive, and then you are trying to like give the points which like you are giving very high amount of points to do the computation. So it will just exponentially increase the computation for the cubic spline, and that will be the worst case for the cubic spline. But yeah, in general, this gives the best result if the data is sufficiently low, and also it is smooth. Yeah, so this is all the comparison between the interpolation algorithms which we have, and where to use it, in which way it will be more efficient, which way we should not use it also. With this, we can conclude with this video. And yeah, in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be happy to help you with all your queries. Have a great day ahead, and happy learning MATLAB. Thank you.